So today is the last class, and today we are going to cover NAT, and I am going to share videos of DMVPN and GRE tunnel. Okay, you guys can manage VPN through recording. Okay, now let's begin. In last class yesterday also we were discussing about the requirement of NAT, why we come up with NAT technology, and one major reason behind it that why we come up with NAT is to save IPv4 address, because earlier when IPv6 was not developed, then it was a big concern that how to save IPv4 address, because there was shortage of IPv4. Total number of IPv4 address is around 3 million only. So that is the reason why we come up with subnetting. That is the reason why we come up with NAT, so that multiple user or multiple organizations can use same private IP address. Okay, and NAT is a technology which is used to make communication possible between private to public network, or you can say public to private network. And purpose of netting is to save IPv4 address. Now we have some terminology in NAT, like inside local, inside global, outside local, and outside global. There are four terminology. These are zone only, right? As I told you in last class, we have two zone, inside zone and outside zone. Guys, in this diagram you can see I have two network. This is inside network. Let me use my marker. Here you can say this is inside network and this is outside network. Fine, let's say this is my network and this is network of Google. Okay, so inside source means source IP address before translation, means this IP address, the network which you are running in your inside network is called inside local. Fine, inside global means your public network. This is your public network, so this is called inside global. Inside global means your public network. Inside local means your private network. Your private network and your public network. Okay. After that, outside local. Outside local means destination IP before translated, means this private network, remote private network. Remote private network is called outside local, and remote global network is called outside global. Outside global, let's say this is network of Google and this is my network. So this is inside local, this is outside local, this is inside global, and this is outside global. Outside global means Google public network, and outside local means Google private network. Inside local means my private network, and inside global means my public network. Is it clear, Nirav and Suresh?
Clear, sir.
Clear. So let me move. After that, as I told you, there are multiple types of NAT: static NAT, dynamic NAT, and PAT. Let me discuss all one by one. First, static NAT. Static NAT is one-to-one translation. Whenever you want to translate one private IP address into one public IP address, you will use static NAT. One-to-one translation. For each private IP address, we need one public IP address. This is not possible. Let's say here you can see I have one topology. In this topology, this is my private network. This is private network of Google. This is my private network. In my private network, let's say there are 1000 users. So there are 1000 private IP address. Is it possible to purchase 1000 public IP address? No. So here we cannot use one-to-one translation, because it is not possible to purchase 1000 public IP address for 1000 private user. Static net is one-to-one translation. Like you can see in this network, there is only one server. So I want to translate this private IP address into one public IP address. So here we can use a static NAT. And through that public IP address, outside user can access my server. Okay, I will show you here. We will configure a static NAT this side. That's why I have added one server here. Here we are going to configure a static NAT, and in this domain we can configure dynamic NAT or PAT. Here a static NAT is not possible. Okay, so let me discuss second types of NAT. And if you want to read more about a static NAT, you have already this notepad, you can read, right? Security purpose, like security, how security purpose? Because we can hide our private IP address. Through public IP address, anyone can access my server. So that's why we are saying for the security purpose, a static NAT is good. To hide actual IP address, exactly. And entry is permanent. NAT translation entry will be permanent in case of a static NAT. It is bidirectional. We will understand this how. After that, if we have multiple user, so we have to use multiple static statement. Let's say we have 1000 user, so we need to create 1000 statement on the router, 1000 translation, because this is a static entry. Okay, after that, disadvantage is convergence of IPs, conservation of IP addresses, right? And max used in server form. You know, when we are using static NAT, whenever, as I told you yesterday also, whenever we want to give access to our server or to our resources which is available on server to outside user, in that scenario only we will use static NAT. After that, dynamic NAT. Dynamic NAT is one to many translation, right? Here we will define a pool of public IP address. Let's say I have 5 number of public IP address, so we will create one pool of 5 public IP address, and we can perform the translation of private IP address to those 5 public IP addresses. So it is one to many translation. One private IP address can be translated into multiple public IP address. So that's why we are saying dynamic NAT is one to many mapping. After that, it is unidirectional, right? It is not bidirectional. We will see while configuration. Entry is not permanent. Entry will be not permanent over here. Let me make you understand how dynamic NAT works. Let's say this is switch, and here I have some user 3, and let's say 4. This switch is connected with one router, and this router is connected with ISP, and here 8.8.8.8. Here we have one loopback, let's say on ISP router 8.8.8, right? Here IP address is 100.1, and here IP address is, let's say, 10.1.1.1. okay, IP address of this machine is, let's say, 10.10, 10.20, 10.30, and 10.40. okay guys, here we have one public IP address. This is one public IP address, and let's say we have purchased public IP address with /30, not 30, /29. We have purchased public IP address with /29. So how many IP address I will get? How many valid IP address I will get? There will be 6 number of valid IP address, right? I will use 2 IP address, one over here and one over here. 2 will be in use, and 4 more IP addresses, more public IP addresses are free. That is, let's say 101.1.2 is the IP address of this interface, 300.1.1.4, and 100.1.1.5, and 100.1.1.6. okay, so we have 1 2 3 4 IP addresses. I will create one pool of these 4 IP address, right? So router will have one entry of these public IP address, like 100.1.1.3, 100.1.1.4, 100.1.1.5, and 100.1.1.6. let's say this user 10.1.1.10 want to ping 8.8.8.8. it will forward the request to router, and router will use any one public IP address from this range. from this pool, it will use any one IP address. Randomly it can use any. Let's say it have translated 10.1.1.10 into 100.1.1.3. Fine, and then it will forward the request to ISP. When ISP will generate reply, again it will translate this public IP address into this private IP address, and then it will forward to switch. Okay, so tell me, at a time how many user can access internet? At a time how many user can access internet?
4.
Only 4 user can access internet at a time. Because if let's say all users are accessing internet, that means this router have used all public IP address in the pool. Let's say 20. For 20 it have used 100.1.1.4 for 100.1.1. Sorry, 10 dot, this is 10.1.1.30. it have used 1.5, and 10.1.1.40 it have used 6. And now here is one more user whose IP address is, let's say, 10.50. so if this user want to access internet, it cannot reach to internet until and unless, one connection will be terminated by router from this pool, because now translation is full. Public IP address for translation is not available. All public IP addresses are in used, right? So this is disadvantage of dynamic NAT. That is the reason why we are not using dynamic NAT nowadays. We are not using dynamic NAT. The third type of NAT is PAT that we are using nowadays is PAT, port address translation. We are saying overload as well, NAT overload. Okay, so dynamic NAT define a pool of public IP address, one-to-many translation, unidirectional, entry is not permanent, and it will depends, its work on FIFO, first in first out. In the end, in the table, if there are 4 public IP address, it will use first public IP address for the first packet, then it will use second public IP address for the translation, then third, then fourth. Okay, and the last type of NAT is NAT overload called PAT, port address translation. Here this is all private user are translated into single public IP address. This is one to all translation. All private IP address will be translated into single public IP address, and it can perform translate multiple user traffic at a same time. Simultaneously it can translate the traffic of all user. And how PAT will work? PAT works with the help of port number. Okay, so in PAT, let's say here we have public IP address that is 1.1.1.1. so for all private user, it will use only this public IP address. Let's say here is one user who want to reach 8.8.8. so source will be this one, 192.168.10.1, and destination will be 8.8.8.8. it will forward the traffic to router. This router will do one thing, it will translate source IP address. Source IP will be become 1.1.1, and destination will be same 8.8.8.8, and it will assign source port and destination port. Let's say source port is P1, destination port is P2. it will assign source port and destination port. After that it will forward to internet router. Now when internet router will generate reply, destination port will be, source port will be P2 and destination port will be P1. so whenever it will receive a reply with destination port P1, this router will came to know that I need to translate public IP address into what private IP address, into 10.1. at the same time, let's say if this user also want to access internet, so here source will be 30.1 and destination will be 8.8.8.8. it will forward the traffic to router. This router will translate source means 30.1.1.1 into which public IP address? 1.1.1.1. Destination 8.8.8.8. And for this traffic, let's say it have assigned source port P3 and destination port P4. Whenever it will receive reply where destination port is P3, it will came to know that I need to translate the public IP address, this 1.1.1 public IP address, into this private IP address 30.1. Getting my point? Is it clear, Suresh? Is it clear to you?
Okay, sir.
Clear.
Yes.
Okay. So now configuration is very easy, guys. First of all, I am going to configure here in this scenario. Let's say which type of net you want to configure over here. You tell me. Which type of net you want to configure over here. IP configuration on router number 1. We have one loopback. We have some virtual interface. Why we have some virtual interface? Because you can see we have multiple VLANs over here. VLAN 10, 20 and 30. That's why we have virtual interface.
Router on stick.
Yeah, router on a stick. Okay, and on fast Ethernet 0/0 IP address is 1.1.1.1. We are going to configure NAT for multiple VLAN. So configuration will be same, don't worry. Okay, and on WAN interface IP addresses you can see 1.1.1.1. Let me check internet router configuration. Here we need one loopback. Okay, so here we don't have any configuration. Let me configure this router. We will configure only IP address on internet router, except IP we are not going to configure anything. Host name, recording is on, yes. Host name, let's say ISP, and interface loopback 1. IP address is 8.8.8.8, 255.255.255.255. Exit interface F0/0, say no shut, and IP address is 1.1.1.2, 255.255.255.0 or 30. So run interface F0/0/24 0. Okay, then interface F1/0, here no set, and this side I am using IP 2.2.2, so 2.2.2.2, let's say 255.255.255.0. Done. Write the configuration. I'm going to close the console of internet router because we will not configure anything on internet router. Now router number 2. Here let me verify the configuration first. So IP interface brief exclude unassigned. So IP address on WAN interface is 2.2.2.1 and on fast Ethernet 1/0 IP address is 192.168.100.100 100.100. Okay, here it should be 20.100 100.100 100.100. Okay, and we don't have any NAT configuration, so run interface F0/0. We don't have any NAT configuration over here. So IP configuration is done. First of all, I am going to configure my private network. So let me take you to R1. On R1, first of all, you need to define inside and outside interface. So fast Ethernet 0/0. This is inside interface or outside interface? IP NAT outside.
Outside.
Exactly. Then interface f 0/0 1/0 dot. So IP interface brief exclude unassigned dot 10 20 and 30. Interface range f 1/0/0/10 f 1/0/1/0 dot 20 and f 1/0 dot 30. These interfaces are
Inside.
I cannot use range command over here. Okay. Interface f 1/0 dot 10 IPNet inside.
Inside.
Interface f 1/0 dot 20 IPNet inside, and interface f 1/0 dot 30 IPNet inside, right? Or directly we can define inside interface, we can say interface 1/0 IPNet inside. We can run this command also. After that, we need to define source. So my source is my interesting traffic. I will create one access control list. Through access control list, I will match my source network, because we need to translate source address. So we have to define the source address. Okay, so access list, let's say number 10, and I will create this access list with permit statement and 192.168. Let's say 0.0. In this network, all the private network will match in this entry. Yes or no, brother?
Yes.
So I am saying enter. After that, IP NAT inside source list number 10. So match source from list number 10. IP NAT inside source is from list number 10. Match from list number 10, and then translation to which addresses you want to translate. What is the public IP address? So here, if you are using dynamic net, so you will use pool. After that, pool of name of pool CCNA. This is the configuration of dynamic net. But here directly I am going to configure PAT, so I am not going to use pool. In the pool, it is very simple. Here you can use pool and the name of pool, and you can create one pool, and in that pool you can define the range of public IP address. Here I am going to tell to router that translate all the source into the IP address which is running on interface fast Ethernet 0/0, and one keyword, that is overload for PAT. This is the NAT configuration only. This is the NAT configuration. Now can I ping 8.8.8? No, I need to define one default route on edge router towards ISP 0.0.0, 0.0.0, and next hop is 1.1.1.2. Ping 8.8.8.8. I'm able to ping 8.8.8, and from LAN user, is LAN user able to ping 8.8.8? Source fast Ethernet 1/0.10. Source I cannot ping like this. I think source, let's say 192.168.10.100. See, ping is working. That means this LAN user can also ping 8.8.8 from VPC. From this VPC you can check. All user of VLAN 10, 20 and 30 can ping 8.8.8, can access internet. IP 192.168.10.1/24, and default gateway is 192.168.10.100, and ping 8.8.8.8. Why ping is not working? Ping should work. Let me ping the default gateway first. Ping 192.168.10.100. Even I am not able to ping the gateway, that's why I am not able to ping 8.8.8. What is the gateway IP address? 192.168.10.100. And here I think on switch I need to define VLAN. On switches we need to define VLAN. And what encapsulation protocol I am using on router number 1, let me check. So run interface f1/0.10. Encapsulation protocol over here is
ISL by default.
we are not able to see encapsulation protocol. So run I think here we have not defined encapsulation protocol .1q. Encapsulation protocol is .1q. So I am going to configure interface E0/0 and switch port trunk encapsulation .1q and switch port mode trunk. After that, interface E0/1. This interface switch port mode access and switch port access VLAN 10 exit interface. Today we have covered inter VLAN routing was router on a stick as well. Switch port mode access and switch port access VLAN 20 exit interface E0/3 switch port mode access and switch port access VLAN 30. Now let me check VPC 6 is able to ping 8.8.8 or not. First I am going to ping the gateway. Now ping should work. It will work after 30 seconds I think. So IP all 10.1 gateway is this one. Everything is fine. No, why ping is not working. On switch we can check one thing. So MAC address table, and what is the MAC address of VPC? 06 in the last. Here is the 06. It is learning the MAC address of this PC on this interface. That is fine. And this is the MAC address of router. It is learning on E0/0. Everything is fine. So ping should work. Now can anyone tell me why ping is not working, Nirav? Ping 192.168.10.1. From here also I am not able to ping PC. What is the problem? Interface F1/0 no IP NAT inside. There is some problem between router and PC, but from router you can see I am able to ping 8.8.8 from the LAN interface. That means LAN user can access internet. From 20.100 also VLAN 10 user is also able to ping, and VLAN 30 user is also able to ping. There is some problem between router and PCs. Let me do one thing. Interface F1/0.10 and say no IP NAT inside. And now I am going to ping one more time again to PC. No. But this switch is learning MAC address. This is the MAC address of router interface. This is the MAC address of router interface is in VLAN 1. So run interface f1/0.10.10. Here we have some mistake, I think. So run on router number 1. Encapsulation protocol for VLAN 10. No, we don't have any problem. This is correct. Oh, fast Ethernet 0/0.10, and here you can see fast Ethernet 1/0.10, and encapsulation protocol is VLAN 20. So this is problem. First of all, here I need to run no interface f 0/0/0.10, no interface, this interface, and then interface f1/0.10, and say encapsulation .1q for VLAN 10. Now it is correct. Now again I am going to ping this PC, and this time ping should work. So run one more time. Let me check running configuration. (1/0.10) encapsulation protocol .1q for VLAN 10, and here we don't have IP address because we have changed the encapsulation protocol, so IP address is removed. IP address 192.168.10.100.255.255.255.0 and ping 192.168.10.1, and you can see ping is working now. Now from VPC 6 you can see it can ping 8.8.8. Now it is able to ping their default gateway, so now it can ping 8.8.8 also. Ping 8.8.8.8. Why ping is not working? Because we have removed IPNet inside command from interface f1/0.10 on router number 1. Again I am going to add the command interface f1/0 IPNet inside. Oh, on sub interface I need to run this command now. Interface f1/0.10 and IPNet inside. Now see, PCs are able to ping 8.8.8. This is the dynamic NAT configuration. Okay, and on router number 2 I am going to configure a static NAT, and you will see after configuring a static NAT, anyone can access this server, like VPC6 can access this server through public IP address. We can hide the private IP address of this server, and for that reason only we are using a static NAT one-to-one translation. Config T. Then first we will define inside and outside. John IPNet outside interface f1/0. This interface inside. And what is the command to configure a static NAT? IPNet source IPNet inside source static. Source is this time static. What is the IP address of source? 192.168.100.1, and then You can define the public IP address or you can define the interface. So public IP address is 2.2.2.1. I want to translate this private IP address into this public IP address. Now this will be bidirectional. Either it can translate this public IP address into this private IP address or this private IP address into this public IP address. If router 2 will receive request for this IP address where destination is, let's say router 2 is receiving one packet where destination is 2.2.2.1, automatically it will translate the destination into this IP address. Okay, after that enter. That's it. I don't need to configure anything else over here. This is the static NAT configuration. So IP NAT translation. You can see the entry. This is inside local and this is inside global. Is there any information about outside local and outside global? No. Now I am going to check the IP configuration of server. On this server I am going to define IP 192.168.100.1/24 and 192.168.100.100 is the gateway. On router number 2 I need to verify once that gateway is correct or not. So IP interface brief 100.100. Now here on router number 2 we need to define one default route towards ISP. So IP route 0.0.0, 0.0.0 and next hop IP address will be 2.2.2.2. Done. Now can server ping 8.8.8? Ping 8.8.8.8. Yes, server is able to ping 8.8.8. And can these user like VPC6, can this PC ping to server? Let me try. Ping 192.168.100.1 is the IP address of server. Destination host unreachable. It is not able to ping, but if you want to ping the server, you can ping the server through public IP address. What is the public IP address of server? 2.2.2.1 and you can see ping is working. Guys, it is not pinging router, it is pinging server, this server. Okay, so this is the NAT only. Now if any confusion, any doubt, you can ask me. Otherwise I have already one question of Nirav, but I haven't checked that. This is the last class, so let me give you some overview of private VLAN as well. See guys, here I have one switch. Okay Nirav, this switch is have connected with some server. Let's say here we have one server, here we have one more server, here we have one server, and we have two more server. Let's say what I am saying that these two server, first two server are HTTP server, second two server is let's say any other server, FTP server, and these two server are let's say any other domain, let's say server for management purpose. Okay, this is HTTP server. Now if you are thinking that why we have two HTTP server, so for redundancy, outside users are accessing this server, HTTP server, two FTP server are there. FTP server, and here we have let's say which server, let's say DNS server, and this is DHCP server. What is my requirement? My requirement is HTTP servers should communicate with each other. And let's say here we have one admin. This admin is also connected with this switch. This is switch. And after that, this switch is connected with, let's say, one router, and router is connected with, again, ISP. And outside user are accessing this server. Here on this switch, my requirement is something like this. Try to understand the requirement. My requirement is these two servers should communicate with each other, but these two servers should not be able to communicate with these two servers. And again, FTP servers can communicate with other FTP server but cannot communicate with HTTP server. And let's say DNS server should not communicate with DHCP server, or DHCP server should not communicate with DNS server. And all means HTTP server should not be able to communicate with FTP server, or FTP server should not be able to communicate with DNS server, and DNS server should not be able to communicate with HTTP server. But this manager should be able to communicate with all server. Or let's say here we have this interface, means this interface is pointing toward internet, so this interface should be able to access all the server. That means, you know what I want, these two ports should communicate with each other, these two ports should communicate with each other, these ports should not be communicate with each other, and this server means manager can communicate, this port can communicate to all ports, and this port can also communicate to all ports. This port can also communicate to all ports. How you will achieve this task? Tell me your idea first. How you will achieve this task?
Sir, create different VLAN and no inter-VLAN routing for those broadcast domains.
If okay, let's say if you have put these two machine in VLAN 10, this two machine in VLAN 20, this machine in VLAN 30, this machine in VLAN 40, right? In which VLAN you will put this user? Let's say VLAN 50. Now what you will do?
Okay, sir. Then again,
Getting my point?
yes.
So here private VLAN comes in picture. Through private VLAN easily we can configure this scenario. You know, we can achieve this scenario with the help of VLAN ACL as well. But we need to create lots of statement. But with the help of private VLAN we can, you know, easily achieve this task.
Oh,
So don't worry, I will give you one video. That video will guide you, right, with example and configuration on real devices, because I think private VLAN configuration is not possible on simulation software. So I have configured private VLAN on real devices. You can watch that video and you can learn the concept. Okay.
okay.
Anything else?
Nothing, sir.
And I will share DMVPN video as well. So please, you guys will complete DMVPN, because DMVPN is part of my syllabus. That's why I am saying you, requesting you. I have not covered only one topic, that is DMVPN in the course. Otherwise, according to my syllabus, according to my plan, I have discussed all the topics.
And what about access points, sir?